I've not seen such bravery.
Yes, I have not seen such bravery than all of you brave souls embarking on the first ever Knox College multidisciplinary game jam. So this is a starter guide so that somebody on your team, preferably the person that's used Eclipse and knows Java, can get the starter code checked out and set up so that you can start developing. So the first thing you're going to need is a GitHub account. Now, if you're a CS person, you want to have a GitHub account anyway, and you want to have code up on GitHub so that when you go to job interviews, you can talk about GitHub knowledgeably, and potentially you can even point to interesting code that you have committed up to GitHub. So go ahead and create an account if you don't already have one. Once you have an account, you're going to fork this repository. So you'll log into GitHub, and you'll go here. So this is KCGJ, the Knox College Game Jam 2016. You're going to need to fork this. You will click this button to fork it. I'm not going to do that because it's my repository. It would look really weird if I forked my own repository. But you're going to do that. Then you'll have something that basically looks like this in your GitHub account. Then what you're going to want to do, copy this address here. You're going to need to check this out locally onto your machine, your laptop, desktop, whatever. Now, your laptop or desktop, if you're running Mac or Linux, you can just use the Git command line tools and do everything from the command line if you'd like. For Windows, I have no idea how to do things command line because I don't really know much about the Windows command line. Git does have a wonderful client program that lets you run all the programs it runs on Windows. I've used it briefly on Windows when I've had to. And I know it also works on Mac, although I just use all the command line stuff on Mac because that's what I learned. But the GitHub client should work for this part. So in whatever way necessary, get GitHub set up and do a clone operation. So I'm going to do that myself here in the project's Git folder. I'm going to do git clone this particular address that I just copied. And dun da da da. Look at that. It's been cloned. So if I go, into here, into Knox College Game Jam and look at all the files, everything is in there. Fantastic. So that's gotten us through the first couple steps. Now once we've cloned it, either using command line or GitHub's software client tool, we need to import it into Eclipse as a Git project. So what we're going to do, we'll open up Eclipse, we'll say File, Import, and normally when we import with Eclipse, we do existing projects, but here we're going to import from Git. We're going to do projects from Git. Now, if you don't have this option, that means you don't have Git support for the particular version of Eclipse you have. It comes built in these days for every version of Eclipse I've used for the last couple of years. If you don't have it for some reason, you can install it using the software update install new software thing under the help menu on Mac. I don't know where it is on Windows. Install new software. The software package is called eGit for Eclipse Git. Come on, let's try that again. File, import. So we're going to say projects from Git. Now we're going to say existing local repository because that repository that we forked and then cloned, the cloned version is now on our computer somewhere. That's what we want. Now what we're going to want to do is add the repository. I actually already have it because I've done this. This is the third take of this demo. But what you'll do, you'll click Add, you'll browse, and then you'll navigate to wherever you just cloned that thing, and then click Open, and then click Finish. I'm not going to do that because I happen to already have it. But once you do, it should show up here. You're going to say Next. You're going to import the existing Eclipse project. Now you can tell it's an Eclipse project because it has a .class path and a .project file. Various other types of IDEs, JBuilder, NetBeans, IntelliJ, they're going to have some different way of handling the meta information for the class path and things like that. I just happened to learn Eclipse first, so that's what I used. They all seem to be about the same. So we're going to say Next, and that's what we want. We're going to want to import that. So we're going to finish, and da-da! There it is. We've got it. And you'll be able to see over here, master here means this is the master branch, the trunk, essentially. Cool. So we've got it. Now, yours may not compile. You may have a red exclamation point here. That's because everything comes pre-configured to run with Java 8 for the Mac. So if you go in here under Problems and you're seeing some complaints about the version of Java, you can come down here, right-click, go down to Properties, and you can go to Java Compiler. And, enable project-specific settings. You can maybe shut this off and then, change the version, or I don't know, you probably don't want to mess with this stuff, but you certainly could if you wanted to. I'm not going to do any of that because I don't need to. But that's how you could change your version of Java. Now, once you've changed the version, if you come up here to Java Build Path and click on the Libraries tab, you may have, I'm configured for the JRE system library Java 8. You may not have Java 8. You might be running Java 7. You may even be running Java 6. Just click on that and remove it. Do Add Library, JRE system library. You can try your workspace default, or try an alternate JRE. You can look for other installed things. You can try to add new ones. If you don't know how to add it for your particular operating system or particular version, ask the Google. But you can basically get the correct version of the libraries for the particular version of Java that you want to use. I'm going to stick with Java 8 because I know that it works. So that gets us how to mess with the version of Java. The next thing is your native libraries. It's pre-configured for Mac. So if you look here under natives, you'll see natives-mac.jar. Now that means that I'm using the native libraries for Mac. Native essentially means Java is going to call into C. C is considered the native language because the JVM and all the underlying stuff is actually implemented in C. And the thing we're calling into is actually some lightweight connector to OpenGL to do the graphic stuff. So if you need to configure this for Windows, you'll just remove this, and then you'll click Add Jar, and then you'll go into the lib folder and pick the proper natives for either Mac, Windows, or Linux. I'm going to just sort of re-select Mac. Now, there's actually one more step we need to do. I'm intentionally not going to do it because I want to show you a very common error message that you can get. So if we click OK, everything should compile at this point. We've got a correct version of Java, and we've got the correct version of natives. The problem is, if we go in here to Scroller, this is one of the sample programs, and try to run it, watch what happens. Go over here to console, bam, it actually crashes. We're getting an unsatisfied link error, no LWJGL in Java library path. Now what this means, that natives, that's Java code, but they sort of look like a bunch of interface methods in that they have the method heading but no bodies. The bodies are actually written in C. So we've got Java methods trying to call into implementations that are written in C so that we can call into OpenGL code. So what this means, it's a pretty easy way to fix this. If we look here in this native folder, we've got a whole bunch of useful code in here. We've got JWJGL, and we've got different versions of it. We've got DLLs, that's Dynamic Linked Library, that's for Windows. We've got SO, those are shared object files, those are for Linux, and dylib, that's the Mac equivalent. These are the native libraries, the code written in C, that's going to give us this lightweight connection into OpenGL that we're going to need to get this stuff to work. We don't have that connected in right now. We have these files sitting here, but this, we didn't tell it how to find it. So the way we're going to fix that is actually very simple. We're going to bring up our properties again. We'll go Java Build Path. We'll go Libraries. This natives, we're going to open this up. You see the native library location is set to none. Well, that's not true. We actually have a native location. So we're going to click Workspace. We're going to scroll down until we can find it. You'll probably have many, many, many fewer projects in here than I do. At least I hope you do. There we go. We're going to open this up, and we're going to click on natives. We're going to click OK. That looks good. We're going to say OK, and then we're going to say OK. Now when we run this, it actually should work. There we go. And so you can see, check this out. We've got a little tank. It can drive around. You can see this. It sort of looks like it's moving. The treads are kind of getting a little bit of a nice animation. We're crashing into water, so we're not able to sort of go very far with this water here. We're driving around even more. Life is good. Fantastic. Totally, totally awesome. So, let's come back over here. So that's the scroller demo. Now, the scroller demo, you notice it has this gigantic map. The map is actually a format called tiled. So let me show you some stuff about the map and about the sprites. So let's open up the scroller. What's really cool about this, if we kind of scroll down, you notice only 250, 260 lines of code for that entire example. Now, the key method to get things started is init. This initializes things. It's loading a sprite sheet, test data scroller sprites. So if we go in here to test data scroller and we look at sprites, you can see this is the tank in various states as it's driving. You can see it basically looks the same, but we've got this slight change in the treads. And then these are the 4 tiles that we're using for the map background. Now, you'll also notice we're loading test data scroller map.tmx. Well, let's open that up. It doesn't have an XML extension, but it's basically an XML file. We're going to say open with XML editor. You'll get this error message. You can just say don't show this again. It doesn't really matter. And so you can see XML, it's basically like HTML. It's another type of markup language. It's a little bit stricter. Actually, it's a lot stricter than HTML in its formatting. So you can see we're saying the tile width and height is 32. We can say the map is 50 by 50 made up of 32 by 32 tiles. Here's the sprites.png. That's that same file. And then down here, tile set layer is 50 by 50. And then actually we've taken that and we've zipped it up using gzip and kind of stuck everything in here. I'll show you what that looks like in a second expanded. But this format here is tiled. Now there's actually a separate standalone program for tiled. You can find the link to it on the site for the Game Jam. I'm going to go ahead and run it. I've got the Mac version installed. So this is what the program looks like. Now I'm going to say open. And I'm going to go into that project, the Knox Game Jam project that I just checked out. I'm going to go into test data. I'm going to come down here to scroller. And I'm going to go open up map.tmx. So you open this up, you can see there it is. There's the map. It's even got a mini map so that you can kind of scroll around. So when you're building your maps, you're not really going to build them by hand. You can actually build them using this program. And I don't actually know how you plug new tiles in. I don't know if you have to change the sprite sheet first. You probably have to. I don't know what any of these buttons do. I haven't really messed with this very much except just to verify that it worked. It's a really, really nice program for doing map generation. Now you might be looking at this and thinking, well, that's fantastic, except I want a procedurally generated map. Now it's got this little die in here. I have no idea what that means. That's something you can look up. But let me show you one other kind of cool trick. I've got this map2.tmx in here. I actually generated this from map1 using tiled. Let me show you what this looks like. If I open this up with the XML editor, top of it looks very, very similar to what we had before. The difference here, yeah, it's 50 by 50, but we're actually telling you what each of these tiles are. And this tile GID, I don't know if this is row or column major order. It's basically giving you all the, 50 tile. The first 50 tiles are the first row, and the second 50 tiles are the second row, and so on. Basically, this is like tile 1, tile 2, tile 3, tile 4, or possibly this is tile 0, tile 1, tile 2, tile 3. In fact, that's probably the case, that this is 0, 1, 2, 3. Let's see if any tile zeros show up in here anywhere. That's how we'll know. Seriously? This is taking forever. Yeah, this is really big. I guess that's why everybody compresses it. No, I guess we've just got tiles 1, 2, and then there's some 3 and 4s in there. Okay, cool. Yeah, so that's what we've got. Tile 1, tile 2, tile 3, tile 4. So it looks like it starts counting at 1. So what you could do is actually generate the map you want, in some sort of 2D grid, either in 2D array or an array list or something like that, and then basically generate this file and save it somewhere, and then open it up using your, basically by doing this. You could sort of create these on the fly if you wanted to. There might be some way to tell Tiled to generate them procedurally. I don't really know. It's something to figure out. So finally, one other thing I want to show you. There's one other sample program in here called Light. So there's a light test. If we run this, check this out. So we can hit L to turn the light on or sort of spotlight it, and then we can hit C to turn on colored lights. This is actually really cool that we have lighting that we can go ahead and apply to the actual sprites and the background tiles that we have. This would have been very hard to do back in the olden days with the NES. At least I think it would be very hard to do, which is why things were either fully lit up or not fully lit up. So I don't really know the full extent of this, the full power of what you can do with this, like with these colored lights. And, you know, sort of with you can see there's like kind of a nice even fading from where it's lit up and where it's not. That's actually really cool, and that's where the LWJGL, the OpenGL lightweight bindings, are going to really be beneficial. But again, like I said, I don't really know the full power of this stuff. So that's something that you'll have to explore and figure out. And just kind of as a note, a couple of other notes. I don't know, we've got tons of different, I don't know, cross.png and cursor.png and, you know, I don't even know what half this stuff is. Dungeon tiles.gif. You got tiles for different kind of generic looking dungeons. This all comes from Slick2D, which if you look in here, Slick2D and Slick2D source, this is the library that we're using to do these 2D game development in Java. It's an open source two-dimensional game engine for Java. And this is a whole bunch of sample stuff that Slick2D comes with. Doesn't have a ton of running code except for kind of what I showed you, the scroller and the light test. So there's a lot of stuff that you'll have to figure out. It does have documentation. It does have a wiki. It's not extensive documentation, but again, it's open source and completely free, so can't really complain too much. So that's everything that I've got to get started. How would you make it a side scroller? How would you make it a platformer? I have no idea. There might be other examples of Slick2D games out there. I've seen a couple of people that have like Java applets that you can run, but I haven't really seen too much other source code, just the one I've been able to find. I haven't looked extensively, so I'm sure some of it's out there. So Slick2D tiled, go ahead and get GitHub, check out the code, get it plugged in, get it started, and, you know, get going, get developing. Let's close with another sound effect from, oh yeah, wait, here we go. We'll close with another sound effect from Gauntlet. Here we go. Ready? And...
Welcome.
Awesome. Welcome to the wonderful world of Knox College's 2D Game Jam.